Hey, welcome back to physics. Today we're going to talk about projectile motion made simple. Essentially, there's two equations we're going to be using with projectile motion, and we've talked about these two equations. There are distance equation that involves acceleration, time, and the initial velocity. We have our y equation and our x equation. Now, what I want you to understand is that 90% of the time, if not more, 90% of the time, if not more, it's going to simplify down into these two equations. YF is going to be where it lands. Well, where's it going to land? It's going to land at the bottom of the cliff, so the height is 0. It's at 0. YI is the height. They want you to find how tall it was, so I put an H in there, how the height. VI, well, if you think about a cliff here, typically we're talking about things that are coming off in this with that type of speed, which means it's all x velocity. There is no y velocity at all. There's no arrow going down. So this part goes away. Notice I don't have it in the bottom equation. Over here on the right, we're talking about now where does it land? Well, almost always we can assume this to be 0, and that would be xi. So that drops out of the equation. The other thing is once it leaves the cliff, there's nothing accelerating it. So this part of the equation goes as well. So you notice I don't have it in the equation. So when it comes to projectile motion, I would say again 90% of the time you're dealing with these two equations right here. And what you're going to do then is you're going to ask yourself, what is the question asking? If it's asking me to find, let's say they're asking you to find how far from the bottom of the cliff did it land? Well, that would be XF. What you have to do then is use the other equation, all right? Because that's a variable and we don't have time yet. What we're going to typically be trying to do is find time and then go into the right equation. So whatever they're wanting you to find, whatever equation that variable is in, use the other equation to find time initially. Again, if they were asking you to find how fast did the car or whatever it was come off the cliff, well, that would be the initial velocity in the x direction. Use the other equation. If they're asking you to find the height of the cliff, then you're going to have to. That means they're giving you enough information to use your x equation. All right. So let's look at an example here. A motorcycle is traveling 20 meters per second, runs off of a cliff, it lands 140 meters from the bottom of the cliff. Find the height. They just asked me to find the height. So they want me to find the height. Well, because they want me to find the height, I'm going to use my other equation to start off with because I'm going to find the time. So that is XF equals VIT. I'm doing this to find the time. The initial velocity is 20 meters per second. It lands 140 meters away. Time is 7 seconds. Now to find the height, I'm going to go into my other equation. YF equals the height, and actually it's 0, equals the height plus 1 half gt squared. The height is what I want to find. The time is 7, so it's 0 equals h plus negative 4.9 7 squared. What you get here then is negative h, once I take the h to the side, equals negative 240.1, or the height of the cliff is 240.1 meters. Exact same problem, worded differently. All right, this time, motorcycle is traveling 20 meters per second. It runs off a 200-meter cliff. How far from the bottom of the cliff does it land? I left out does, but it's does it land? Well, now they're wanting me to find XF. How far from the bottom of the cliff does it land? Well, that means I'm going to use my other equation. I'm going to use my y equation over here, or my height equation, to find the time. 0 equals h plus 1 half gt squared. 0 equals 200 plus negative 4.9 t squared. 200 equals, I'm going to make it just positive 4.9 t squared, and now I got to solve for t. T turns out to be 6.4 seconds. Well, now that I know time, I can go into my x equation and find out how far did it fall, because it was going 20 meters per second for the entire 6.4 seconds. So xf equals vit 20 times 6.4. xf equals 100 and I don't know, see, it's multiplied out here. 128 meters. Well, hey, I hope that helped simplify projectile motion for you guys. I'll catch you guys on the flip side.